Hello, and welcome to Coding Koans, where together we will explore the world of software, get better jobs, and change the world. My name is Ian Carroll, and I voted. And you can too, and you should. If you're in the United States, and then you should vote. If you're in another country that has elections, you should vote there too. Voting is very important to do. It is, a right, and a liberty is only such if you use it. If you don't, it's the same thing as not having it. So definitely go out and vote. Okay, on the show with me today, I have Brian Sung, and let me get his bio up. Oh, hey, Brian. Hold on a second. Go for it. You can talk now.
You can go through the bio if you want.
Oh yes,
think
yeah.
I,
Let me do that with you. I mean, you're here anyway. You're gonna watch me do this in front of you, but before it seemed less awkward to the audience because you weren't here.
how about I'll step away and then you can give the bio.
Oh, that's great. Okay, here we go. Brian is a software engineer at 8th Light and a recent graduate of the apprenticeship program. He prefers working on the front end with React as a strong suit and is interested in learning more front-end JavaScript frameworks. He also enjoys photography, baking bread, and playing acoustic guitar. Brian, welcome to the show.
Hey, Ian, thanks for having me. And I'm glad to be on the show tonight.
Excellent. Good, smooth introduction there.
Oh yeah.
All right. So I need to ask you a few questions. So you're a recent graduate of the apprenticeship program. You've been working at a company called 8th Light, which is the company I work for as well, for about a year now, right?
Yes, that is correct.
Okay, cool. Tell me, so when people hear apprenticeship, a lot of times they think internship. Do you think there's a difference between those?
Yes, I would say that internship is more just fulfilling basic tasks without really having much guidance along the way. Whereas apprenticeship is kind of like following that, apprentice or student master sort of model.
Mm-hmm.
And so in this apprenticeship, you'll have mentors who pretty much just guide you along the way. They're not going to hold your hand per se and like tell you exactly, this is the way to implement things, but they will put you on the right path, and it's pretty much up to you to, you know, take it as far as you can.
Yeah, I'd say that seems about right. That was my experience as well.
Mhm.
Um, Let me ask you a few questions about that apprenticeship. Like, what do you do in the apprenticeship if you're not performing basic tasks that no one else wants to do?
You're learning a lot. So if you want to like get down to the nitty gritty on what we actually do, we do a lot of like tic-tac-toe. We'll implement a web server, which is like something that the average programmer probably doesn't really deal with
You
too
build
much.
a whole server from scratch, right?
Correct.
Mm-hmm.
Yep.
Okay.
And you'll learn about different programming paradigms like functional programming. You'll learn about design principles, mainly like solid principles. And then, yeah, it's just a lot of learning, pretty much.
Cool.
Yeah.
Well, yeah. I mean, yeah. That's sort of like my experience with it is like at least with Eighth Light's apprenticeship, you were paid to learn. You get paid to do things that are not of any value to anybody yet, but the skills that you develop will be of value to the company later. So it's like an investment on the company's behalf and saying like,
Okay.
yeah. Speaking of which, maybe I can share my screen with you. Um, just do that real quick. I want to go over some of the stuff that you did during the apprenticeship, actually.
Oh no. All right. Yeah, go for it.
Uh, where am I going to find you? I guess we'll do it this way. There are 6 Brian Sungs.
Nice. Oh, Brian Sung.
So here we go. So we have an eBay, which is an eBay clone, but with an I. That's one thing you did in Ruby. Here's your web server in Java. Here is a Ruby tic-tac-toe. Here's a Minimax Ruby tic-tac-toe.
Oh, that's actually a Ruby gem.
That's a gem.
Yes.
So you made a gem that was your Minimax. Did you use that gem inside of your Ruby tic-tac-toe?
Correct.
Oh, that's so sweet. Oh man, I really wish I had done that during mine. And then you have Elixir here as well, which is the language we're going to be working on today. So let's take a look at see how that Elixir thing turned out. Was this your first tic-tac-toe when you did Elixir, or was it like second or third?
What do you mean when I did Elixir? Was this the first one?
First time you coded up a tic-tac-toe challenge.
Oh, okay. So it was supposed to be, except, and I guess we can just talk about this more in depth later, but the whole idea of functional programming was just so hard for me to grasp at that moment. So I went back to Ruby and did Ruby tic-tac-toe first, and then went back to Elixir.
Okay, so it was both your first and your third.
Pretty much, yeah.
like Grover Cleveland was president, both the 22nd and 24th presidents of the United States. This Elixir program is your first and third one. Nice.
Yeah.
Cool. Well, looking here, I want to get into functional in a second because I think that's going to be a cool thing to really dive into. But I'm seeing, so here's your README. Elixir tic-tac-toe application features: human versus human, easy computer games. You can support 3x3 and 4x4 boards. So I guess you didn't get to the impossible one for this one, did you?
That's still in a PR.
Oh, really?
Yeah, it just never got merged. I think we just like wanted to like go past that. So
all you had to do was hit the button.
Yeah, I know, but I think I don't know. I'll just go back.
Did I find the PR? Is it still here? Yeah, it is. Let's see it.
It is.
How old is this PR? Oh my goodness! Look at this. Adds Minimax. Here we are.
Oh yeah, that persistence layer is pretty cool too. So I implemented a database and it saves pretty much the last 3 moves.
Okay, so persistence layer, if you didn't know what that meant, because it took me a second to remember what that meant, a persistence layer means that instead of the tic-tac-toe app remembering only what it knows while it's running, it saves its data someplace else so that even when you turn it off and turn it back on, it remembers its history. And it uses, and in this case, you used a database to accomplish that, right?
Correct.
I'm guessing probably MySQL?
It was Postgres.
Postgres.
I believe.
Yeah, both of which are relational databases, and I guess you used an ORM for that as well. Did you use Ecto?
Mm-hmm. Correct.
Ah, I'm smart. Okay, that's enough of that. Yeah, it's funny. You still have these PRs here.
Yeah, 2019, October 3rd. That's almost a year from now.
Yeah. All right.
Jeez.
What I really like about this is not only do you have how to play and how to run the test, but you also have how to contribute in case someone else wants to do that. Of course, you're still going to have to merge those PRs in.
Yes.
Okay, so let's talk a little bit about what makes Elixir a special language. So you said that you started off with Elixir as like your first language that you tried. You found it to be really, really hard to sort of grasp the concepts in that language. So you went back to Ruby for a while, and then you came back. What's the differences between Ruby and Elixir?
So the biggest difference is Ruby is object-oriented, or is an object-oriented language, whereas Elixir is not, and it's a functional language, meaning everything is immutable. So there's no concept of state in a functional programming language.
No concept of state. All right. Yeah, I don't understand the concept of state yet. Let's imagine for a second that I know nothing about programming, and I don't know what you mean by state. Like when I hear state, I think the state of California, or separation of church and state, or some such. What do you mean by state?
So pretty much just like any piece of data, I would say. So I guess an example would be in an object-oriented programming language, such as Ruby, we can create people objects. Let's say we have a human object or something that has a name attribute or an age attribute or something like that.
Okay.
If I wanted to create a person, I could just instantiate this human class and give it, a name and age. And then the name and age would pretty much, that would be sort of the state that, or like the data that that object has at that given moment. So, I can do other things, and then if I wanted to like console log the name and age, I can just, how would I say this? Like, just go back to that object and then access those fields and console log them. And it stores that data in that object.
Right. So another form of state would actually be a persistence layer, such as a database that remembers what things happened before.
Yes.
Right. So these are my Lego Beetles. Each one of these, each one of these Lego Beetles is a Lego man, right? Or a Lego person. Now, this particular Lego man is John Lennon. And, right, is that John Lennon? Yeah, that's John Lennon. So, and John Lennon has the same interfaces as any other Lego person. It's got the same top, same bottom, same sort of, cylindrical head. You can put hair on him. You can give him a little telescope. You can change the color of his pants or whatever, or his legs, because really, with a Lego man, there's no such thing as pants. They're just plastic bits of leg, right? We just make them think that it's the illusion of pants. But that's the same class as this Paul McCartney Lego man, right? And the only difference is that, this one has different bottom, different top, different haircut, different face, and he carries around inside and this is love, right? So an object-oriented programming language is designed to sort of simulate what it's like to have actual things. And it focuses on what the thing is, rather than giving like a list of instructions, which is usually when you think of a program, you're thinking first this, then that, then this, then that. Like if I go to a theater and I ask for the program, they're going to give me a little booklet that has a list of the people who are on the cast, and then Act 1, Act 2, Act 3, and maybe a little bit about each of the songs that they're going to sing in there, assuming it's a musical. But yeah, this is object-oriented programming languages have people and they have things in them that do a job, such as a bicycle might be in a object-oriented language, and that bicycle object may be composed of other objects, 2 wheel objects, a handlebar object, a gear object, a chain object, and a method in which you push the pedals and the bike goes. And so it's designed to wrap the programming in a metaphor that as a human being you can understand. Now, functional programming languages don't do that at all. They don't use objects. They don't have state. They don't have any of this. So what is it, like, what do functional programming languages do that like object-oriented ones don't?
They don't have any side effects. So
no side effects. Okay, that's an interesting idea. So like you know, if I don't think we have side effects on actual objects like this. I can't really do this as an analogy. So you don't want side effects. Side effects such as like, oh, if I take out the trash, it also launches the nuclear arsenal.
Right.
Right. You know, I brush my teeth and it stops every bus in the city of Shanghai. That's an example of unintended, unexpected side effects that can happen in the code. You don't get those in a functional language, or at least you're supposed to avoid them. Is it possible to even have side effects? I think you can.
Well, maybe you can, but I just know that like it definitely reduces the amount. I don't know if it like just doesn't have side effects completely, but there are fewer side effects, if not any.
So, yeah, for me, a way of describing the difference between a functional language and an object-oriented one is that an object-oriented one is about matter, about things, and functional is about energy and the flow of that energy. It's not about the data as a stateful thing, it's about the flow and the transformation of that data through a system. It's much like you would have a method in a class, like pedal the bicycle wheels. Instead of having that be like a thing inside of the object, that's all that you have. You just have pedaling, you just have gear turning, you just have going. And so it's a very different kind of way of doing things. Okay, that's probably enough theory because we're over a couple of minutes at this point. You want to just do some code?
Yeah, let's get into it.
All right, cool. Do you have? Did you get that link to my VS Code?
Yes, I did. Let me join. Whoops, I did not mean to rejoin the Zoom.
Oh, well, fine to have you twice.
I think this should work now.
Cool.
Am I in?
Do I see you? No. Here, let's do it another way.
Wait, hold on. I think I just need to authorize VS Code on GitHub.
Okay.
Okay, it should be working now.
All right. Are you seeing it?
I am not. Is there another link?
There's another way we can do this, and it might have like stopped or something like that, live code. So I'm just going to share my screen. Oh, zoom, 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 share. Okay. Well, we're back to looking at the screen here, and you can see we have our Elixir. And then inside of Elixir, we have our new leap thing. Now, let's see. We've got a lib, we've got test, we've got a formatter, we've got getignore, we've got mix.exs, and then we have a readme. What would you like to start
with? Let's, we can take a look at the readme, I guess, see what's in there.
Sure. Let's just move this up a size so that other humans can read it. All right. Leap. Given a year, report if it is a leap year. The tricky thing here is that a leap year in the Gregorian calendar occurs on every year that is evenly divisible by 4, except every year that is evenly divisible by 100, unless the year is also evenly divisible by 400. For example, 1997 is not a leap year, but 1996 is. 1990 is not a leap year, but 2000 is. If your language provides a method in the standard library that does this lookup, pretend it doesn't exist and implement it yourself. Notes. Short exercise, very simple rules. There's more to learn. Delightful minute explanation. The whole leap year phenomenon. Go watch this YouTube video. That's useful. It's nice of it to have a YouTube video link inside of a README. Writing the tests, you do mixed test. So maybe we can CD into this. Elixir leap, right? And then mix test. Okay, so we got 4 tests, 1 failure, 3 excluded. Test vanilla leap year. Expect truthy, got nil. So we have.
So are these tests already written out?
Yeah, they are.
Oh, okay.
So if we go in here, there's a test helper, and here's our tests. And it looks like this one is commented out. I just realized I don't have any syntax highlighting for Elixir in my VS Code.
Oh, no. Should be fine.
.ex, let's just look for that first. There. I really want to be able to see that syntax highlighting.
Author's name is 1 letter off from our coworker.
Huh. Maybe he's hiding something. Maybe he has a secret pseudonym that's exactly his name, but with 1 character different.
That's interesting.
Ah, there we go. Syntax highlighting is back. Yay! Okay, cool. Now, this is going to be a lot easier. Syntax highlighting, a very nice thing to have. So your strings come up in this color, other stuff in another color, so you can tell what's what, and you can more easily see if you made a mistake. Because when everything suddenly turns orange like that, you go, oh, I see what I did. Okay. Cool. So let's see here. We have, so this tag, right, has been commented out. And I don't like comments, so I'm just going to delete that. We'll just delete the tags as we go through. It should still fail, because load-bearing comments are a terrible thing. Okay, cool. So we have assert year equals that, and then we have this year.ex over here. This is interesting. Let's open this to the side. All right, I got this doc here that I don't want to care about right now, so I'm just going to get rid of it. That should still pass, or it should still fail for the same reason. Yeah. And then we have this def module year, and then do. This actually does look a little bit like Ruby. The syntax looks like Ruby.
Yeah, it's pretty similar.
And then we have @spec, leap year, non-negative integer, Boolean. So I'm guessing this is like some sort of type checking?
I don't think it's like strict type checking, but more of just like, it's like describing what it should be. But I think if it like, I'm not sure actually.
Do we even need
I wonder
this?
if you like return a string, if it will fail or something. But I don't know.
It might just be a, oh, it create a warning. Let's see what that warning is.
I think the warning is saying that year is not, yeah.
Yeah, That's interesting. All right. I'll know. Can we do this? Is that proper syntax, or do we need to use the return key?
That's proper syntax. You don't need, I think it's implicit returns.
Now, year is technically truthy. So this is not, this is a dynamically typed language, not a statically typed one in that case, right? because
Is that what it means?
well, I mean, what is is there a way to quickly print this out?
It would be io.puts.
io.puts.
Io being capital.
Okay. io.puts. Do we wrap it in parens?
You can
Like that?
try that.
I'm not
Is it
seeing it.
io.puts? Admittedly, I haven't used Elixir in a while.
No worries, we'll figure it out. We have the whole of the internet at our disposal. What's really interesting is this is not printing when I do it that way either.
Oh, so io.puts, interesting. It requires that year is a string, or whatever argument is passed into puts is a string.
And it just fails silently when it doesn't do that?
Yeah.
Okay.
I think so. What you can do instead of using puts is use inspect.
io.inspect.
Mm-hmm.
Whoa. Why'd that happen?
I don't know. Yeah.
All right. It's got to be that formatter.exs in there. That's probably our linter that is auto-formatting the file for us. It still isn't seeming to print anything out. Oh, there it is. Year 1996. Right? There it is. Okay.
Why is it printed there?
I don't know. Is there a way to do the type on this? Does Elixir have a way to do that, like .type or something?
Let's see.
I mean, it's not object oriented, so technically it shouldn't do that. Objects can have properties like type, but in a functional programming language, all you have is data. So how do you tell whether the data is one thing or another?
Off the top of my head, there's something called like guards that you can do. Like, so if you want a function specifically only taking in a certain type of parameter, you can implement a guard. So like, let's say you have a function that you only want to pass in like integers to, then you can implement this guard for that function so that if this guard is true, which is usually like is this variable, like the syntax is like is integer or something like that.
Mm-hmm.
You can implement this guard, and so that gives you sort of that confidence that, hey, I know the type of this parameter or argument.
I was just trying to print out what the type was. That was kind of what I was hoping to be able to do.
I think you can do that in Elixir, actually. There might be...
Oh, here it is still. It's in there. Each time we've actually printed it out.
Huh. Type of.
Yeah, it just shows up like in the middle of the line. That's all. All right, cool. So okay. Well, technically this passes the test, and that's all that we needed to do. This is our spec. So as long as it does that, we're good to go for the next one, right?
Mm-hmm.
It's just kind of interesting that it's passing so easily. So any old year should not be a leap year. 1997 is not a leap year. Oh, that's kind of fun. That's actually useful, because false is not a leap year would not be as useful a message. But because of the fact that it's returning the whole number, whatever the input is, it's actually saying 1997 is not a leap year. Okay. So how do we get this thing to check to see whether the year is a leap year or not?
Well, the simplest thing you can do, which would be like writing the least amount of code to get this test to pass,
Right.
would just be a conditional that
Okay.
checks if the year is 1997.
So how do we do that in Elixir?
If year,
If space year.
yes. And I don't remember if we need parentheses, but I can verify that. Yep, double equals 1997.
Oh my gosh.
Yep. And then I believe you need a do after that.
Okay.
Yep.
And then we need an end between that and the other, right? Do we need to do an early return?
Well, you don't even need a return because it's either going to be one or the other.
I
So
thought the year is just going to execute no matter what. And then if this is true, whatever's in here will.
yeah, I don't think you need to return it though. You can just do, you don't need to specify return. So you can just type false.
Or nothing.
Actually, I'm curious. I don't, admittedly, I haven't used Elixir in forever, so.
Well, the other test is still passing. Is there an else that we could use instead? Because like here, no matter what, we're ending up returning year.
So yeah, you would do else after the do. And then you can put the year in that.
Okay.
Or true, I guess, or false.
I kind of like the fact that it's right now it's giving us the name. Oh look.
So I guess like null is falsy, I
This
suppose.
is clearly not what's meant to happen. So I'm gonna force you to pick another random year. Let's pick 1987. Because this is how you get around cheating. You write another test. So 1997 is not a leap year. Oh, weird. What? It should have been 1987 is not a leap year. Oh. This string is what's returning. Gosh, I thought it was something really cool, and it's not. It's just this string. I am so disappointed. There we go. 1987 is not a leap year. Which means that I think now we can just do true here, right? It's not magical. It's really plainly obvious. So just read what's in my freaking face. It's right there. Oh man, so many times with software, that's what you end up doing. You end up not reading what's right in front of your face. Like if you could just let your ego go, let your expectations go, and just read what's in front of your face, you'd be an excellent software engineer.
What's that acronym? RTFM?
Read the effing manual? Yeah. Yeah. Okay. Well, we just discovered something about the human condition in addition to software, which is not uncommon. You code the software, but the software also codes you.
Ooh.
Yeah. It's like having too much of the spice melange. Slowly, it changes you.
I'm not sure I understand that reference.
It's a reference to Dune, which is an old science fiction book. they're making a remake of the movie coming out soon too. That's exciting. Oh, speaking of which, you were drinking something a little before the stream, so cheers to that. And the reason I referenced that, and also this, is because there is a show on Outpost 13 called I Effing Love Whiskey, where it's Andrew Pierce and Joseph Limbaugh, both excellent geeks who try different scotches and famous whiskeys, and they have a guest and they talk about whiskeys, and it's delightful. So yeah, that's another show you should definitely check out on Outpost 13, along with so much content, so much varied content. We're the only software show on here, or I should say, yeah, this is the only one so far. But maybe there are other ones coming down the pipes. Who knows? Better keep my guard up. That's not a veiled reveal of the fact that there's going to be some sort of other coding show. There really isn't. This is it. Any case, we got this failure now, and the failure says the right thing, and we're now just using true. I guess we could use false if we want to be explicit here, just because having it read is nice. Okay. So how do we get this to be not just for 1997? How do we pass this next test?
You can simply just add or after 1997.
You son of a...
year. I think you need to specify the expression again.
All right. Gonna make me do another test? I'll do another test. To figure out some other years that are definitely... if 1996 is a leap year, then
1995.
1487? I don't think that's a leap year.
No, I think any odd number would not be a leap year.
Okay. So. All right, how do you pass this test, smart guy?
Well, we can simply just add another or statement, but now we're getting into a sort of a pattern.
Right.
And
because we can't just write down or for every single number in all of existence.
No, that would be insane.
Yeah.
You could, but I mean, why? I mean, I guess no one is telling you that you can't. But...
Leap year is like a 5,000 line long file that catalogs every year between, that someone could reasonably ask for, but of course it won't go beyond the year 10,000. So, and a whole bunch of things just rely upon this one piece of software that someone wrote ages and ages and ages ago. And then one day in the year 10,000, the thing fails to work, and then, whatever constitutes planes in that existence, some sort of, gelatinous goo that transports you from one destination to another suddenly starts eating people, and whole planets just dissolve from this goo because of the fact that somebody 10,000 years earlier wrote this code this way in such a lazy fashion. All right, so how do we make this so that it works for all time?
So you can do something that checks if it's even or odd. So I guess what we're seeing the pattern is every single test that is sort of like we're refuting that it's a leap year.
Okay.
All those years are odd.
Okay.
So it seems like, hey, odd numbers aren't leap years.
Okay.
So we could simply just do the remainder.
So a modulo.
Or modulo.
Yeah. So how do you do that in this language?
I believe it's just
mod 2?
I think it's that. Let me just verify.
So mod 2 is a modulus, which means that every 2 times it's just going to give you what the remainder of the division is. It's basically like hands on a clock. So right now the clock only has 2 points. So it's either 0 or 1 based off of the fact there's only 2 positions for it. So if it divides evenly by 2, it's 0. And therefore, it's an even number. Now we could abstract this if we wanted to. If this is too confusing, we can actually say it's even and then have this inside of that function, right?
Mm-hmm.
But
I guess in this case, it would be equals to 1 because we're checking if it's odd.
oh yeah, that's true. So if it's, but I like the idea of leap years or even years. So I like the idea of doing it this way. If it's a leap year, true. Else, false. Okay. Leap years or even years. Now that we know that's not entirely true, and I'm going to prove that in a second. Syntax error.
Oh, is it not? Does it not like that? Okay, I guess the other alternative is rem. So replace like pretty much that whole year, modulo 2.
Rem.
Parentheses. Year, comma 2.
Oh. And see if that's the remainder of year and 2 is 0.
Mm-hmm.
Now is it the remainder of, I'm wondering if this is backwards. Well, that worked. Now I'm going to have to do another test.
Yet another any old year. An even old year.
I'm trying to form a thought here, and you're not helping.
Are you testing even year? That is not.
1998 is definitely not a leap year. Okay, what do we do with this one?
So if we go back to the README, or if memory serves me right, it says a leap year is something that's divisible evenly by 4.
Correct.
So we could just replace that 2 with the 4.
Okay. And that's about as far as we're going to be able to get today. But you did an excellent job of being as lazy as possible, forcing us to write out a very complete set of tests, which actually is a hallmark of good test-driven development, which is what this is. So we're allowing the tests to force us to write just enough code and nothing else. So that way we don't end up with a whole bunch of cruft that doesn't do anything and just looks fancy and can contain bugs. So we know this is working. That's good. Cool. Okay, I'm going to stop sharing for here, and let's get back to, let's talk about what we learned today. So, Brian, what did you learn? Or perhaps, what did you wish to express to those based off of your approach to software? You wanted to make sure that you emphasized, or what we discovered.
So what I wanted to express is when you're doing TDD, always take like baby steps. There's something called Green Refactoring, and all it is just write a test that fails, write enough code. So that like writing the test that fails would be the red part. think of it as like a stop sign or a stoplight. So you're writing a test that fails, you're kind of like hindered on progress. You can't make any progress because you don't have any code to make that test pass. And then to get a green, you just simply write enough code. And that's the keyword, enough. You don't have to write the whole solution out. And I think what we did earlier in that exercise was just return the year,
Yeah.
which was enough to get it to pass. So that's all we need to do. And then we keep doing that until we get to the refactor, which was, the point where we have so many of these years that we want to test. And instead of having to write or blah, 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 like 500 times or whatever, that's when we refactored the code. And what this refactoring did was modify our function so that it still passes every single test. So that's one thing to emphasize. Another would be, I promise I'm better at Elixir. I just kind of forgot all the syntax, and it's been a while, but I promise I'm somewhat proficient in it. And yeah, hopefully whoever's watching this can get something useful from this talk. I know I'm not the best speaker, but Ian definitely is a great speaker, so.
Sure. I will accept that compliment. Thank you. All right. I got a couple of questions to ask you before the end of this. We also learned the differences between a functional programming language and an object-oriented one, right?
Yes. Or, yeah. In
Or at
theory,
least,
yes.
yeah, a little of the differences. We also talked about, we explored Elixir. It looks a lot like Ruby as far as how it's written, but it is a very different kind of programming language. We didn't yet get into what Elixir is based off of. Because it's based off of another programming language.
Mm-hmm. And you want me to tell them what it is?
Say the language.
It's based off of Erlang.
Yeah.
And that's another functional programming language.
True. And it's one that I have not had any experience working with, except occasionally updating the Erlang version for old Elixir code every once in a while, or getting the wrong Erlang version and having that cause headaches. Erlang is Erlang. It's the Ericsson programming language, and it was created by Ericsson, which is a telephone company, and it is a telephone software language. So when Erlang developed it, they developed it so that it would work for telephone systems and be able to handle vast numbers of concurrent processes happening at the same time. So you would have, a traditional single-threaded language can do one thing at a time. So someone asks a question, it stops what it's doing, it goes off, figures that out, gives it back. But what happens if you've got millions of people trying to make calls all at the same time, and you need a language to be able to handle all of them at the same time? Erlang is a language that can do that. It can. It's very good for concurrency, and because of that, Elixir, which is built on top of Erlang, also has those benefits. So it makes it a language that is very useful if you are going to have a very large customer base or a large number of users who are going to be using your system at the same time, all asking for things simultaneously. And being able to give everyone back quick results and exactly what they're asking for. That's where it's really useful. So that's what I know about it. That's kind of high level, meaning not close to the metal, meaning not necessarily an engineering thing, but it's something that I sort of understand about how that language works. But I have not actually coded as much Elixir as what Brian has. Brian wrote an entire tic-tac-toe app, and that might not sound like much, but you'd be surprised how complicated tic-tac-toe can be uh, to write it well. You might have seen in there was like a couple hundred lines. Like, I mean, there are, I don't know, probably a few thousand lines of code to just make a tic-tac-toe app, all broken into different files and each have their own thing that they're doing. That's just good coding, because if you don't, it becomes a nightmare trying to maintain that. But yeah. Okay, Brian, two questions for you. One, what is the most important thing to remember about being a software engineer?
I would just say have fun with it. Like, don't try to compare yourself to like, I guess like the elite people or whatever. Just do what you can, have as much fun. Because if you're just comparing yourself to others, at the end of the day, you're not going to get anywhere. You're just gonna like, you know, bask in, oh, why am I not as good as this person or whatever. Just have fun with it. Don't like like I don't want to say don't take it seriously, but like don't take it like too extremely seriously. Like
Don't be too precious with it.
yeah,
Is that a way of saying that?
yeah.
Yeah.
Like just have fun with it, and if you want to make it your career, then there is a level of like seriousness you should take, but don't make it so it's like you're just adding so much unnecessary stress on yourself.
Right. Yeah.
You know, take
Um,
it step by step. You know, and then if you end up becoming a software engineer, write code in a way so like I like this philosophy of like if you're working on a code base, put it in a better spot than when you found it, because 9 times out of 10, someone else is going to pick that code up. And if you just leave it in such a good state, you know, they're going to thank you so much.
yeah, because it'll make their job easier. And that person might be you 2 years later.
Exactly. So you would be thanking yourself.
Yeah. Cool. All right. So let's say that I don't know anything about code and I've just been faking it this entire time. What would be the first thing that I would do in order to actually learn the programming languages that I keep saying that I know?
A good starting point would to be to pick like one programming language, and I've heard it mentioned here so many times. Just pick a programming language and get good at it, because most of the time, all that knowledge will transfer into other programming languages. Unless it's like, you know, going from object oriented to functional, you know, that's going to require a bit more effort. But if you're just like, for example, learning Ruby, which is an object-oriented language, and you want to get into like Python, for example, which is another object-oriented language, then you know they're so similar in terms of concepts that the hardest part would just be learning the syntax, like how it's supposed to be expressed. The concepts are, you know, there. So
Yeah. Slightly different, but it's like different Romance languages.
right,
Um, you know, no, you can't go to someone who is speaking Spanish and speak Portuguese to them and have them understand you, but it'll help you when you learn Portuguese if you already know Spanish.
mm-hmm.
Yeah. By the way, I'm not sure if do you know many languages, Brian? Have you learned any like human languages besides English?
I Well, I'm Korean, so I know a little bit of Korean, but admittedly, I'm really bad
Okay.
at Korean. So I only know English, and I took Spanish class in high school, but
So,
that's,
all right. Would you say it's easier to learn Spanish or to learn Python?
I would say it's easier to learn Python because, you know, it's already in words that you know how to understand,
True.
like in terms of like expressing it, but kind of like getting that structure might not be as easy in terms of like how to structure code.
Yeah, that's an art form,
But you know,
admittedly.
whereas Spanish, it's like it uses English letters, or I guess would be Latin in this
Yeah.
case. But it's not in a structure that you know how to understand.
Right. So yeah. Um, yeah, because I think sometimes the idea of learning a language intimidates people. So thinking of it in terms of like this isn't like a human language. This is just a set of instructions that a computer can understand,
Mm-hmm.
and you get to determine how that language is structured. Like, you get to determine like how how you express what it is that the computer is going to do. So yeah, it's more like creating. It's more like writing poetry, or you know, I'm not sure if that's better for someone. Some people are really intimidated by poetry. Um,
Like me.
okay, bad analogy. uh, but yeah, okay, cool. But it's good to know that, and I found that to be true too. Having tried to learn Spanish, tried to learn German, tried to learn Chinese, um, uh, learning computer programming languages is so much easier. There's not even a comparison in my mind. But I don't know. It might just be me. I hope not, because I really want other people to know how to do programming. I,
Did you find that learning other or like once you knew a programming language, did you find that learning others were easy?
oh yeah,
Not easy, but like simple.
yeah. It was just a
Sure.
matter of like, oh, how do I blank in this language? You know,
Yeah.
how do I write a loop in Clojure? That turned out to be very different than writing a loop in an object-oriented language like Ruby, uh, because there's like literally no state, so you can't loop through something. You can't iterate.
Yeah.
So you have to have a whole different way of iterating, and I had to like completely re-understand what it meant to do that in that language. But still, I'm still trying to do the same kind of thing, and the language is going to have a way to do that, you know. And besides, you don't need to know it fluently. I don't need to know every single bit of syntax. The user manual is the entire internet. So at any time I can look it up, and I don't have to be writing code as fast as I can speak. I should write the code as fast as I can think, which turns out to be a lot slower than how fast I can speak.
Mhm.
Well, thank you very much, Brian. Okay, so that's pretty much the end of our show. I have a few people to thank. Production liaison is Matt Pittner. My designer is Aaron Harvey, and he has a show on this on Outpost 13 called Infinite Trek, where he talks about Star Trek. Matt Pittner has a show as well called Crockpot Cinema, where he watches old movies and makes food and drinks. While you watch the show with him. My marketer is Lucas Vanosic. He is frequently on a show called Two Liars, which was a game show, and that's on Thursday nights, if it's still running. May have taken a hiatus. Bot Master is Cody Bushy. He's in charge of the bots. And he has a show called An Actor Unprepared, where he has an actor, a director, and a writer, and he puts them all together and he makes them make a piece right there on the spot. And the music that you heard before and what you're going to hear after the show is done is by Alex Sanders, or sorry, wow, Alex Sanders and Arlo Khan. No, Arlo Sanders and Alex Khan. Oh my goodness, those two guys are so linked in my mind that I'm shipping them. Sorry, guys. They have a show called Made Up Music, and that show is done for now, but you can listen to all of their songs on Spotify. Just search for Made Up Music. Yeah, that's pretty much the show. Now it's time for the awkward goodbye that usually happens at the end of any software video conference. Are you ready for that, Brian?
Yeah.
All right. I'll see you later, Brian.
All right. Take care, Ian.
Bye.
Bye.
Hold on. Bye. Wait.
All right.
Uh,
I'm gonna press the leave button now.
okay. Hold on. Wait.
Oh.
Okay, I think we're done. No, wait. The volume is still on.
And if
Okay.
anything, we can just slack about it.
Yeah. Okay, bye.
All right, bye, Ian.
I walk this life, the only steps I can, steps too high. I'm just a man. If you see my face at your hour of death, don't shake. Don't shake in your boots, no, don't you fret, 'cause I'm gonna take you down where the beats are pumping, down to hell where the lava's jumping, in the mountain lava's jumping, down to hell where the lava's jumping.
Let yourself fall, 'cause you'll only get higher. Let yourself drop like a bee on fire. Living half dead, so you might as well drop. The f***ers can't find you, the beat don't stop. The beat don't stop. It'll never stop.
I walk this life, the only steps I can, steps too high. I'm just a man. I walk this life, the only steps I can, steps too high. I'm just a man. When you start saying a mountain is a mountain, a river is a river. But living Zen, a mountain is not a mountain, a river is not a river. After learning Zen, a mountain is a mountain,